All right, let's dive into the hidden world of power. We're going to be talking about the absolute giants of the electrical grid, these massive pieces of equipment that literally stand guard over our entire modern world. So, think about it. You've probably got a breaker panel tucked away somewhere in your house. But what's the real difference between that little box and the colossal equipment it takes to power a whole factory or even an entire city? Well, that's what we're going to unpack, and trust me, the answer is pretty cool.
Okay, first things first, we gotta clear something up. You'll hear people use the words panel and switchgear almost like they're the same thing. They are not. They have totally different jobs, and getting that straight is the key to understanding, well, pretty much the whole power grid.
Let's start with what you know, the electrical panel. You can call it a distribution board, a breaker panel, whatever. Its job is simple, really. It takes one big feed of power coming into a building and splits it up, sending it safely to all the smaller things that need it. You know, your lights, your outlets, your fridge. It's the local traffic cop for electricity.
Switchgear, on the other hand, is a whole different beast. It's a much bigger category of super heavy-duty gear that's designed not just to send power out, but to switch it, to control it, to isolate huge circuits, and most importantly, to protect them when things go horribly wrong.
You know, the source material puts it just perfectly. It says, panels distribute loads, while switchgear manages power system events. So think of it this way. Your panel is handling the normal, everyday flow of electricity. Switchgear, it's built to handle the chaos, the once-in-a-decade crisis, like a massive short circuit that could take down a whole city block.
To really get a feel for this difference, we've got to think about scale. So let's go on a little journey. We're going to climb what I like to call the voltage ladder, starting right where you are and going all the way up to the power plant itself. So we start right here in the low voltage world. We're talking anything up to about 1,000 volts. This is the electricity that's all around us, in our homes, our offices, our shops. This is the home turf of the electrical panel. Now let's take a big step up the ladder to medium voltage. Suddenly, we're in the industrial backbone of our world. This is up to 52,000 volts. This is the kind of serious power you need for massive factories, sprawling hospital campuses, and the utility substations that feed our neighborhoods. This is true switchgear territory. And at the very top of the ladder, you've got high voltage. This is the transmission superhighway. This isn't about powering one building anymore. This is the massive switchgear that manages the bulk flow of power across entire regions, making sure the grid itself stays stable. Okay, so we get the mind-boggling scale. But what's actually going on inside these giant metal guardians? Let's crack one open, figuratively, of course, and see what makes them tick. Inside, you've got this whole family of components working together. For the main power, the big kahuna, you have air circuit breakers, or ACBs. A step down from that, you've got molded case breakers, MCCBs, for big industrial machines. And way down at the end of the line are the little miniature circuit breakers, MCBs, which are the kind you have at home. Everything is connected by what's called a bus bar. That's the backbone. And the whole operation is run by the protective relay. That's the brains of the system. Now that backbone, the bus bar, it's absolutely crucial. It's basically just a huge, thick piece of metal that carries all the power. And engineers face a classic choice here. Do you use copper or aluminum? See, copper conducts electricity better and lets you build a smaller unit. But aluminum is way cheaper and lighter. It's that classic engineering trade-off, performance versus cost. But here's the thing. When you're managing this much power, you're also managing immense danger. There's one particular hazard, a really violent one, that all of this engineering is designed to prevent, and it's called an arc flash. So what is an arc flash? Well, forget what you think of as a spark. This is an electrical explosion. It is a violent, terrifyingly fast release of energy. We're talking about a blast of intense heat, blinding light, and a pressure wave that can throw a person across a room. It is, without a doubt, the single biggest danger for anyone working with this equipment. So how on earth do you tame a lightning bolt in a box? Engineers use a multi-layered defense. First, they design systems that can trip a breaker in a few thousandths of a second. Second, they use devices that literally choke off the amount of energy available in a fault. Third, they build it so you can operate it remotely, keeping people far away from the danger zone. And fourth, they actually build enclosures that are strong enough to contain and redirect the blast away from anyone standing nearby.
Now, this kind of technology has been around for over a century, right? But what's happening now is a complete digital revolution. This old school, heavy duty hardware is getting smart. It's learning to talk, and that changes everything.
Think about the difference. The old way was all reactive. You'd go out and inspect a piece of equipment every 6 months, and you'd fix it after it broke. The new way, with smart switchgear, is totally proactive. The gear is packed with sensors, it's networked, and it's constantly reporting data. It can actually tell you it's about to fail before it ever does.
And the benefits of that? They're huge. You get way less unplanned downtime, you can send maintenance crews exactly where they need to go, and you get a real-time picture of how energy is being used. And it all leads to the most important things: better safety for workers and a much more reliable grid for all of us.
So, we've climbed the voltage ladder, we've peeked inside these metal guardians, we've seen how they're getting smarter. What's the big takeaway? Why does any of this hidden engineering actually matter?
Well, for one, just think about the sheer scale of it all. The global market for switchgear is expected to be worth over $120 billion pretty soon. This isn't some niche industry. This is a massive, absolutely critical part of the entire global economy.
But really, it all comes down to this. Every single time you flip on a light switch, you are plugging into this unimaginably vast and complex system. And switchgear, this hidden world of engineering, is a silent guardian that makes sure the power is just there, safe, reliable, and ready whenever you need it.
And that kind of leaves us with one final big question to think about. Our electrical grid is getting smarter and more connected every single day. But all that new intelligence also brings new complexity and new vulnerabilities. So the question for the future is, what new challenges of security and complexity will these guardians of the grid have to face next?